Alright, I'm going to review over optimization today. So I'm going to try to get through several examples. The first one is which points on the graph of y equals to 4 minus x squared are closest to the point 0, 2. So we can try to picture what this looks like. So that's going to be a parabola that opens down. And I want to identify the points that are closest to a particular point. So this one, for instance. And I'm hoping that you're looking at this and thinking, oh wait, there should be 2 points because the graph is symmetric. There should be 1 point on the left and 1 point on the right. So some strategies for doing this, we probably want an equation that we can take the derivative of because we need to optimize it. That's going to be the first derivative test. But we're trying to optimize or minimize in this case. We're trying to find it closest. So we want to minimize what? The distance. So that means we need to find d prime, basically first derivative of d. So in this case, I'm going to use the distance formula between some point, xy, and the point that we want to minimize to, 0, 2. So I have x minus 0 squared plus y minus 2 squared, all underneath the square root. So this can be simplified as x squared times y minus 2 quantity squared. And that's our distance d. But now we haven't tied in the equation of this parabola at all, not to mention we have too many variables. We have a d, an x, and a y, and we're only doing these with 2 variables. So what I need to do here is to substitute my equation. I'm going to get x squared plus 4 minus x squared minus 2 quantity squared. Now this is d. I need to square that whole thing. I can simplify 4 minus 2, so that gives me a 2. And I have a quantity squared in there. So that's going to be x squared plus 4 minus 4x squared plus x to the 4th, which is x to the 4th minus 3x squared plus 4. Now I want to take the derivative of this, and this is d of x, but I really do not feel like doing the power rule and the chain rule. So I'm going to do something a little bit different. I'm going to square everything. So I have a d squared, and that's going to equal x to the 4th minus 3x squared plus 4. Then I'm going to find the derivative, and I'm going to do it implicitly. So that's 2d times d dx equals to 4x cubed minus 6x plus 0. d dx, which is going to be 4x cubed minus 6x all over 2d. When you are trying to calculate the maximum or minimum, that means we wanted to take the derivative like we just did here, which is the first derivative test, and we basically want to find when that first derivative is set equal to 0. 4x cubed minus 6x is equal to 0. Factor out at 2x, I'm left with 2x squared minus 3. So x equals to 0, or x squared equals 3 halves, or x equals to plus or minus radical 3 over 2. So these 3 things right here that I just found are my critical points. And I need to determine which one of those 3 are going to give me the minimum distance. So I need to actually calculate. We need to find the distance when x is 0, the distance when x equals to a positive square root of 3 over 2, and the distance when we use a negative square root of 3 over 2. So when I plug in a 0, I get square root of 4, which is 2. When I plug in radical 3 over 2, I get 3 over 2 squared, so 9 over 4, minus 3 times 3 over 2 plus 4. And the bottom one, I get the same thing, actually. 9 over 4 minus 9 over 2 plus 4, 7/4 underneath the radical. The point, the actual point, closest to 0, 2 are going to be x equals to plus or minus square root of 3 over 2, and the y values. We actually didn't calculate what the y values are. Is it square root of 7 over 4? Not actually, that's the distance. The y value has to come from the equation of the parabola, which is 4 minus x squared. So I need to figure out y equals to 4 minus x squared, which is 3 over 2. So that's going to be 5 over 2. So this is my coordinate point for my answer. I want us to design an open box with a square base that has surface area of 108 square inches. I want to know what dimensions will produce this box with a maximum volume. So another optimization problem, but this time I'm trying to maximize the volume. So let's draw a little picture of this to see what we have. This is an open box, which means that it has no top. It has a square base. It gives us the surface area of 108. And I'm going to actually also call the height y. So if the surface area is 108, then that means the area of the base, which is x squared, plus the 4 sides, which is going to be 4xy, must equal to 108. Okay, but that's not what I'm trying to maximize. I already know what the surface area is. What I'm trying to maximize is the volume. So that means we have to have some volume equation in terms of x or in terms of y so that we can take its or find its first derivative. So let's come up with a volume formula. With the dimensions the way that it's written, our volume is x squared y. But we can't have multiple variables in here. We just need the volume in terms of x or the volume in terms of y. So I'm going to go ahead and look over here to my surface area equation and solve it for y. So that means 108 minus x squared all over 4x. This equals to y and is going to get plugged in over here. So my volume can be written as x squared times 108 minus x squared all over 4x. And we can simplify this out a little bit. I think that would actually be a really good idea. So we can cancel out an x. And then we just have 4 down here on the bottom, and I believe we can divide 108 by 4. 108 divided by 4 is going to be 27 times an x. And then we have an x times another x squared over 4, so that's a 1/4 x cubed. So now I can find dv dx, or this time let me write it as v prime, just to be a little different. And that equals to 27 minus 3/4 x squared. We want to find when v prime of x equals to 0. 0 equals 27 minus 3/4 x squared. We want to find when this is true. So 3/4 x squared equals 27, or x squared equals to 27 times 4/3, which is 36. So x is plus or minus 6. But we're trying to find the dimensions of a box, which is going to be positive x values only, so I'm going to forget about the negative. Our x value actually has a restricted domain. X cannot be anything. So we really should think about our domain for x. And let's take a look over here, because it's going to be restricted by our surface area. X cannot be negative, of course, and it can't be 0, or it wouldn't make much sense for our box, so it has to be greater than 0. But what is the maximum value for x? Take a look at our numerator, 108 minus x squared. X cannot be greater than 108, or the square root of 108. So we have to test our extrema when figuring out what our maximum volume is going to be. So I actually have to check v of 0, which is kind of silly. I have to check v of 6. And I have to check v of 108, which again is kind of silly too. But just as a formality, I'm going to write it out. So the volume, if x is 6, is going to be, and here's our volume equation in terms of x. We can use either one of these. I'm actually going to go ahead and use this one. That'll be 27 times 6 minus 1/4 times 6 cubed, which is going to be 108. So our dimensions are going to be 6 inches by 6 inches by 3 inches. All right, we've got one last problem that I'm going to work out. You have up to 4 feet of wire to form a square and a circle. How much wire should be used for each to maximize total area? Okay, so imagine you have a length of wire and it's 4 feet long. I want to create a square out of this and a circle so that I maximize the area. So I don't really know anything about the square except it's got to be x and x, and my circle has some radius r. So we're trying to maximize the area, and the area is going to be the area of the square plus the area of the circle, so that should be x squared plus the pi r squared. The perimeter of this square plus the perimeter of the circle should equal to 4 feet. Does that make sense? We're trying to build the square and the circle. So the perimeter of the square is going to be 4x because you have to add up all the sides, and the perimeter of the circle is also called the circumference, which is 2 pi r. So we can actually solve for r and plug that into our area equation so we have everything in terms of x. So let's see what we get when we solve for r. 4 minus 4x all over 2 pi, which we can rewrite as 2 minus 2x all over pi. So this is going to go in here for our r. So we have everything in terms of x. Area equals to x squared plus pi times 2 minus 2x over pi, quantity squared. So simplifying this gives me 4 minus 8x plus 4x squared all over pi squared. I can cancel out one of the pi's and leave myself with x squared plus 1 over pi times, you know what, let me take out a 4, times 1 minus 2x plus x squared. And that's the area in terms of x. So I want to maximize the area, so I'm going to find a prime. So that's 2x plus 4 over pi, because it's constant. Derivative of 1 is 0, so I have negative 2 plus 2x. So I want to find when a prime is 0. Okay, remember, don't set a prime equals to 0. We want to find when a prime is 0. Little technicality. So 2x plus 4 over pi times 2x minus 2. Pi is just a constant, so I'm going to kind of just get rid of that by multiplying. So that's 2 pi x plus, I guess I'll let you know what I'm doing here, multiplying everything by pi. So the pi cancels, and then I'll have 8x minus 8. Solving for x leaves me with 8 over 2 pi plus 8, which is 4 over pi plus 4. Our domain for x is actually between 0 and 1, and where I get that is actually back over here to the wire. If I didn't make a circle at all and just had a square, you could think of it that way, I would have used 1 foot per side of the square, or I could use 0 feet and have no square and all circle. I am going to test out what my area is with the 0 wire for the square, the area with 4 over pi plus 4 wire for each side of the square, and area with 1 for the side length of the square. So we need to plug this into our area formula. And it doesn't really matter which one you use. I'd probably go ahead and use this one over here. And I would plug it into my calculator. So if we do that, and we plug it into x squared plus 1 over pi times 4 minus 8x plus 4x squared, we get 4 over pi. And for this one, we get 0.56. And for this one at the end, we get a 1. So what does that mean? Which one of these yields the largest area? Okay, well, clearly not 0.56. And what do we know about 4 over pi compared to 1? Pi is what? 3.14? So that means 4 over pi is greater than 1, so we want to use 0. What does that mean for us? Take a look. X is 0 means there is no square, and it is all circle. So it says how much wire should be used for each. So that means 0 feet for the square, 4 feet for the circle.